This video is about writing linear models. The first problem says a restaurant chain is slowly closing down stores. Suppose that in 2005 there were 3,568 stores and in 2009 there were 3,200 stores. Write a linear equation describing the relationship between time and the number of stores. So what they're looking for here, this linear equation, is really a linear model. It's going to take the form y equals mx plus b. And so what they tell us in this is that in 2005 there were 3,568 stores. In 2005 there were 3,568 stores. And in 2009 there were 3,200 stores. And so it is slowly closing down, so over time there's going to be less stores. We need to name a couple of variables. I'm going to let x represent time in years, and let y is going to represent the number of stores. So let's look at x. X is going to represent time in years. 2005 is the starting time, and so we're going to let that be when no years have passed. So 2005 is going to be x is equal to 0 when no years have passed. And then 4 years later in 2009, after 4 years have passed, x is going to equal to 4. So we can start to form ordered pairs here. When x is 0, or in 2005 there were 3,568 stores, and 4 years later in 2009 there were 3,200 stores. So we have a couple of ordered pairs, and if we have 2 points, these are our points, we can calculate the slope. If we have the slope in 1 point, we can write the equation of a line. So our slope is going to be y2 minus y1, or 3,568 minus 3,200 over, if I started with this point with the y's, I'm going to start with this same point for the x's, over 0 minus 4, which 3,568 minus 3,200 gives me 368 over negative 4, and this ends up being negative 92. This is what the slope means. The slope means that for every their number of stores is decreasing. That's because we have a negative, is decreasing by 92 stores every year. The slope is a rate, so the slope means that the number of stores, the rate of decline of the stores is 92 per year. That's what it means. So here is our formula to put it into a line. Y minus y1 is equal to m times x minus x1. These parts will change depending on what line we're trying to write. So I write y minus, and now I must pick a point. I'm going to go with this one. This is the one I choose to put in here. This will be my x1 and my y1. Y minus 3,568 is equal to negative 92 times x minus x1 is 0. I'm going to solve this for y. Y minus 3,568 is equal to negative 92x. I'm going to add 3,568 to both sides and get y is equal to negative 92x plus 3,568. This is the linear model I've created to describe the relationship between time and the number of stores. Now we're going to use this equation for the second part of this problem, which says predict the number of stores in 2020. So in the year 2020, the starting year was 2005, which is 15 years later. So from our starting point, so this is when x is 15. So y, and I'm just to indicate that this is in 20, y sub 15 is what I want to write down, is equal to negative 92 times 15 plus 568 And so that's going to be, when I do this together, negative 92 times 15 plus 3,568, it's 2,188. And this is stores. This is the amount of stores they have left. So this is stores in the year 2020. That's what that is. Okay, the second problem says the value of a building purchased in 2005 depreciates as time passes. The building was bought at a price of $250,000, and after 6 years, it is worth $214,000. Write an equation describing the relationship between the worth of the building and time. So y equals mx plus b is going to be the linear model we'll come up with. They say it was purchased in 2005 and it was worth $250,000. So this is time, and this is the value, all right? And then it says after 6 years, so after 6 years, that's 2011, it was worth $214,000. Okay, again, we're seeing some ordered pairs. I'm going to let X represent time in years, and I'm going to let Y represent the value of the building. So we have a couple of more ordered pairs. Again, 2005 was the initial purchase, and no years had passed, so I'm going to let X equal to 0 in 2005. So that means after 6 years have passed, in 2011, X is 6. So I can write a couple of ordered pairs. In 2005, the building was worth $250,000. And in 2011, 6 years later, it's worth $214,000. Now I have 2 points. I can calculate the slope. I'm going to say 250,000 minus 214,000 over, and if I start with this point with the y's, I must also start with the same point for the x's, over 0 minus 6. So your slope is going to equal to negative 36,000. Well, I guess that's positive 36,000 over negative 6. So my slope is going to be negative 6,000. What the slope means is that the value of the building is decreasing at a rate of $6,000 per year. Let's write the equation of the line. Y minus y1 is equal to m times x minus x1. These parts will change depending on which line I'm writing. In our case, I'm gonna use this point. That's what I choose to be my x1, y1. So it's gonna be y minus 214,000 is equal to negative 6,000 times x minus 6. I'm going to move my work right here. So this is going to be y minus 214,000 is equal to negative 6,000 x plus 36,000. I'm going to add 214,000 to both sides. I get y is equal to negative 6,000 x plus $250,000. This is our linear model for the first part of the problem. It should make sense to us. If x is 0, that means it's the starting year and no time has passed. That's the year 2005. So if we let x equal 0 in this equation, the first term will be 0, and y is going to equal to $250,000, which is the value of the building when no time has passed. If you let x be equal to 1, it's going to subtract $6,000, and the value of the building will be worth $6,000 less. So that's a good model Part 2 says use this equation to estimate the value of the building in 2018. Well, in 2018, that is 13 years later after the building was initially purchased. So X is going to equal to 13 in this case. So we're going to use this equation right here. It's going to be Y, and this is for 2018, is equal to negative 6,000 times 13 plus $250,000. So Y is going to equal, this is the year 2018, it's going to equal to negative 6,000 times 13 plus $250,000, which is $172,000. This is the value of the building in the year 2018.